Okay, so we are going to now look at something called Cramer's rule. Now, Cramer's rule can be used to solve a system of linear equations. All right, what does that mean? It just means we have something like ax plus by equals some number. All right, so it might be like 4x plus 3y equals 2 or something like that. And then we have cx plus dy equals some number. So that could be like negative 7x plus 3y equals 8. All right, I don't know. It could be something like that. Now, if we have a linear system of equations like this and we want to know what x and y is, now we have already learned using basic algebra, you have probably already learned ways to solve this. You can solve for y in terms of x and then substitute it in. All right. What we're going to learn is a way to do this using determinants of matrices. All right. And we're going to do that using something called Cramer's rule. All right. Cramer's rule is just a way that we can use the determinants to find the answers or to solve for x and y in this equation. And in order to use Cramer's rule, we're going to have to use something called the coefficient matrix. Now, the coefficient matrix is just a matrix that we make using the coefficients of these. The coefficients are the numbers next to the variables. So the variables are x, y, x, y. The coefficients are a, b, c, and d. So the coefficient matrix is just, in this case, it's going to be a, b, c, d, this matrix right here. All right. So that's the coefficient matrix. All right. Now, if we have a system of equations that looks like this, where we have ax plus by equals e and cx plus dy equals f, then Cramer's rule, if we're just talking about a 2 by 2 matrix here, all right, so this is Cramer's rule for 2 by 2. This video, I'm going to focus on 2 by 2, and then I'm going to make a separate video talking about 3 by 3 matrices or 3 by 3 linear systems, okay? So, if this is the case, then we can solve for x like this. What we're going to do is we're going to take, on the bottom, we're going to have the determinant of our coefficient matrix, which is just a, b, c, d. And on the top, we're going to have the determinant of another matrix. What matrix is it? Well, it's going to be a matrix where, because we're solving for x, we're going to take away the x. All right, no, we're going to take away the ac. All right, because those are the coefficients for x, and we're going to replace it with ef. All right, we're going to take it and move it in there. All right, so that means it's going to be ef here, and then we're going to have bd here. All right, so that's how you find x. And then y is similar, all right? Y is similar. On the bottom, we're still going to have our the determinant of a coefficient matrix, which is going to be oops, I messed up there. Hold on a second. It's going to be the determinant of a, b, c, d. And on the top, though, this time, what we're going to do, for the x, we took away the x and put the ef. For the y, we're going to take away the y and put the ef in. All right, so this one's going to be AC, and then we're going to have EF right here. Okay, so that's Cramer's rule. It just tells us that we can find x and y by finding these two determinants and these two determinants. Now, this only works if the determinant of our coefficient matrix is not equal to 0. All right. If it equals 0, then we're going to have 0 down here, and Cramer's rule breaks. It doesn't work then. You have to use a different way of solving the equation. But as long as the determinant of this matrix is not 0, we can find the solution. All right. so here we go. We're going to use Cramer's rule to solve a couple of equations. All right, let's start here. The first thing we're going to do, let's make our coefficient matrix. All right, let's just make it. So here are our coefficients. Our coefficients are 8, 5. Make sure you have your x's and y's. It could be written 5y plus 8x, but make sure you put your x's first and your y's second. All right, keep them in order. All right, so we have 8, 5, and then we've got 2, and this is minus 4, so this is a negative 4, all right, for our coefficient. All right, so this is our coefficient matrix. Now we can easily set up our solving for x. All right, so how are we going to solve for x? Well, on the bottom is going to be the determinant of this matrix, which is 8, 5, 2, negative 4. And on the top is going to be the determinant of a different matrix. Which matrix? Remember, we're going to take away the x's and we're going to put this 2 and negative 10 in. So it's going to be 2, negative 10, and then 5, negative 4. All right, so now all we have to do is solve this. What is the determinant of this top one? Well, 2 times negative 4 is negative 8, and then 5 times negative 10 is negative 50. So we're going to have negative 8 minus negative 50. That's negative 8 plus 50, which is 42. So we have 42 on the top. And then on the bottom, we're going to have 8 times negative 4. That's negative 32. Minus 5 times 2 is 10. So negative 32 minus 10 is negative 42. So on the bottom, we're going to have negative 42. So 42 divided by negative 42 is negative 1. So we have found x. X equals negative 1. Really easy. All right. Next, let's find y. All right. How are we going to find y? All right. Let me put like a line down here so that we know we're in two separate things. All right. And actually, let me solve x equals negative 1. Let's say we know that. Okay. Next, all right, we want to find y. Now, how do we find y? Again, on the bottom, we put our coefficient matrix, which is 8, 5, 2, negative 4. All right. And then on the top, we're going to write the coefficient matrix again, but we're going to take out the y section, which is this part, 5, negative 4, and we're going to put in the answers. All right. So 2, negative 10. So it's going to be 8 over 2, and then we have 2 and negative 10. All right. And so that's all we have to do. So what do we have here? We have 8 times negative 10, negative 80, and then we're minus 2 times 2 is 4. So that's negative 84, all right? So that's negative 80 minus 4 is negative 84. And then what's on the bottom? Well, we already found this, right? 8 times negative 4, 5. We already found the determinant of this is negative 42, right? So we already know this is negative 42. We don't have to do it again. So we end up with negative 84 over negative 42, which, of course, is just positive 2. So we know that y equals 2. And we're done. So we have now solved x and y. X is negative 1, y is negative 2. Problem is over. All right, let's do the same thing over here for this other example. All right, we have, let's make our coefficient matrix first. So we have 4, negative 6. Make sure you keep the x's and y's together. So this is 4, negative 6. This is x's and y's, so it's okay. If it's switched, be careful though. It could be tricky on you. All right, it could be written 5y plus x here, and you need to make sure you switch them so that this column is for x's and this column is for y's. All right, so here our x coefficient is just 1. All right, there's 1 x and there's 5 y's, so there's 5 here. All right, so this is our coefficient matrix. All right, now let's start solving again. All right, we're going to begin with x equals, and on the bottom, we're going to have the determinant of our coefficient matrix, which is 4, -6, 1, 5. And on the top, we're going to change it. We're going to get, because we're solving for x here, we're going to get rid of the x's, and we're going to put these in there, 4 and 14. So it's going to be 4 over 14, not over 14, but 4, 14, and then we keep the y's, which is -6, 5. All right, and now all we have to do is solve this. Find the determinants. All right, so we have 4 times 5 is 20. All right, and then we're going to have -6 times 14. What is that? 60, 84, right? -84. So we're going to have 20 minus -84. So that's 20 plus 84. That's 104, right? I'm trying to do all this in my head right now. Yes, 104. I think that's right. All right, and then what do we have on the bottom? We have 4 times 5, which is 20. And then we're going to minus -6 times 1 is -6. So 20 minus -6, that's 26. So we have 104 over 26. Let me see. 4, does that work? Times 4, 80. Yeah, right? It's 4. All right, it's just 4. All right, so we know that x equals 4. All right, now let's find y. I'm going to draw a line here just to separate it. This isn't anything to do with math. All right, so y equals, and again, on the bottom, we're going to have our 4, -6. This is our coefficient matrix, right? On the bottom, we want to find the determinant of the coefficient matrix. And then on the top, we're going to take out the y's, which is -6, 5, and we're going to put in these, 4, 14. So we're going to have 4, 1, and then we're going to have 4, 14. All right, and we can start to find these determinants. 4 times 14 is 56, and then we're going to minus 4 times 1, which is 4. So 56 minus 4, that's 52, right? And then we have already found this determinant, right? This determinant we've already found, it's 26. So we're going to have 52 divided by 26, which is 2. So y equals 2. Let me check my book to make sure I got these both right. Yep, 4, 2. Good. All right. So we are done. X equals 4, y equals 2. All right. We have solved these equations. That's how you use the Cramer rule for 2x2 system. Now, the next video, we're going to talk about 3x3 system. I'm sorry, today's lesson is going to be a little bit longer.